Good morning, Bronx Arts, seventh grade science. This is Miss Jones. I hope you guys are having a great morning. I will be on this platform in a little while. I just wanted to post a video for you today and just let you guys know that I'm missing you. I'm always thinking about you, and we will see each other soon, hopefully in person. But in the meantime, today's lesson is going to be lesson 13, reading 1. If you join me in the chat room in our meet, we'll be reading it out loud. But in the meantime, I'll be sharing here and reading it for your hearing. So again, it's lesson 13, reading 1. What happens to mass during a chemical reaction in an open system? Open system is something you learned about yesterday. I introduced it in your vocabulary. You didn't actually learn about it, but we'll dig deeper and learn a little bit about open system today. We'll also be talking about it tomorrow. And by Friday, you should be masters of open and closed systems. All right, so the getting ready portion, which as you can see is taken from your workbook, it says, think about a chemical reaction you probably already know, rusting. Hopefully you guys have some information about rusting. Just think about when things rust. What does that mean? Make a list of everything you know about rust. You might think about what rust looks like, what kinds of objects rust, and what makes objects rust, what causes it to rust. So that was your getting ready portion. And when you guys look into the Google Classroom, you'll see that that question is your activator or your do now question. And then after you answer that, we're actually going to talk about rust and what it looks like. So even though you're hearing this, I want you to just jot down those notes first on what you think rust is before you listen to this portion. So even if you have to put your computer on pause for a moment, please do that. And then when you come back, this is what you're listening to. An everyday reaction in an open system. Rust is a product that forms on the surface of a metal as a result of a chemical reaction. Maybe you know that rusting involves metal. Maybe you know that the particular metal involved in rusting is iron. The same chemical reaction causes rust to form on many objects that contain iron, like nails, tools, cars, bicycles, and some fences. Rusting is a complex chemical reaction. It involves reactants and products, like all chemical reactions do, but the reaction has to occur in the presence of water. You may already know this. In fact, when you wrote what you know about rust, you may have written that rusting happens when some objects get wet. For now, you are going to look at the main reactants and products, but not at the water. Water is necessary for rusting to take place, but the water is not considered one of the reactants. Let me repeat that. Water is definitely necessary for rusting to take place, but the water is not considered one of the reactants. Let's see what that looks like. So they're showing you what the chemical model looks like in written form. One way to represent the chemical reaction called rusting is this. So this is what it looks like in written form. On your left side of the screen, you see it says reactants. What are the reactants? It's iron and oxygen. The oxygen in the presence of water. It's iron and oxygen. Where are we getting that oxygen from? Hopefully, you guys are saying the air we breathe. Yes, you guys are amazing. Excellent. And then the product, just the end result, is iron oxide. And again, that's only in the presence of water. So, some type of rain or something, if the item gets wet, over time it starts to rust. That's what they mean by in the presence of water. So, your reactant is what you started off with. You had iron, and then that oxygen starts to touch the iron. Some water mixes in there. That's your reactant. And then your end product becomes iron oxide. Now they want you to compare the chemical reaction of magnesium burning, which was back in lesson 8, with the chemical reaction that causes a bike to rust. So I know lesson 8 was a while ago, You guys might not remember what magnesium burning looks like, so let's just look at a quick little video and remind ourselves about what magnesium burning looks like. One of the things that I really need you guys to remember is when you're burning magnesium, one of the pointers that we said was you cannot look directly at it. The flame gets so bright that it will literally blind you for a moment. So if we were doing this in the lab or at school, you would have had to, number one, had your safety goggles on, and we would not look directly at it. But this is what magnesium burning looks like.
Since the magnesium ribbon doesn't have as much surface area as the magnesium powder, it requires a torch to get started.
You see how bright that light is
The cool thing
getting?
about the magnesium is that
Water
water actually makes it burn even more violently because the heat from the reaction splits the water molecules, which provides oxygen and fuel for the fire.
So again, this is magnesium burning. You see when he adds water to it, it intensifies it.
That's all I've got for this video. See you next time.
So let's just look at that one more time. Let's go back just a little bit. That's the magnesium ribbon at the top, and it's burning.
Doesn't have as
It's a
much
plate of water.
surface area as the magnesium powder. It requires a torch to get started. The cool thing about the magnesium is that water actually makes it burn even more violently because the heat from the reaction splits the water molecules, which provides oxygen and fuel for the fire.
Notice what that magnesium is turning into. You see a white powdery substance forming right there. White powdery substance.
That's all I've got for this video. See you next time.
So make sure you remember that. And then go back to what our assignment is. Again, is compare the chemical reaction of magnesium burning, which we just looked at back in lesson 8, with the chemical reaction that causes a bike to rust. So we're looking at the iron plus oxygen on the reactant side, and then we're looking at that product side, iron oxide. What can you say about both of those? Talk about magnesium burning first, and then finish it up with what you noticed about rust. If you have any questions, please join me in the chat room. I will be there at 10:15. See you then. Thanks, guys.